Hi everyone, this lesson is for geometry students. This is a review of chapter 5 and 6 for your test. And this is part 1, which covers worksheet number 1. Let's get started. First question, find the length of a rectangle, or the length of a rectangle is 2 centimeters and the width is 1 centimeter. Find the length of the diagonal. And so you know with a rectangle, you have a right angle right there. So we're just going to use Pythagorean Theorem. We're going to say 1 squared plus 2 squared is equal to the diagonal squared. So you have 1 plus 4 is equal to the diagonal squared. So the diagonal squared is going to equal to 5. So the diagonal is equal to the square root of 5. All right. Next question. The measure of an altitude of an equilateral triangle is 4 root 3. Find the perimeter. So we're trying to find all the lengths around the outside of the equilateral triangle. And it says the altitude, which is the length that comes straight down. And in an isosceles triangle and in an equilateral triangle, the altitude cuts down here in 2 equal parts, as well as this is perpendicular and makes a right angle. If it is an equilateral triangle, that means all the angles are 60 degrees, 60, 60, and this whole thing is 60. But when we cut it in half, it then becomes 30. So now we have a 30, 60, 90 right triangle. And if the height is 4 root 3, so we have 4 root 3 like that, then across from the 60 is a root 3. So you've got a root 3, this value equal to 4 root 3, which means that a is equal to 4. And a is across from the 30. So there's a, which is 4. And then across from the 90 is twice a, which is 8. So in order to find the perimeter of the equilateral triangle, you're going to add all the sides up. So you have 8, 8, and 8. And then 3 times 8 is 24 units. Right triangle has hypotenuse length of 8 and one side length of 5. So our job is to find the length of the remaining side. So we'll call it x. And we're going to use Pythagorean Theorem. Again, we're going to go x squared plus 5 squared. You're saying leg squared plus leg squared is equal to the hypotenuse. The hypotenuse is always going to be set by itself. And it's the side that's across from the right angle. And so that's going to equal to 8 squared. So we have x squared plus 25 is equal to 64. I'm going to subtract. I'm going to go 64, subtract 25, and I get 39. So I've got x squared is equal to 39. So x is equal to the square root of 39. So that length is root 39. And most of the time we're going to ask you for an exact value, which is this. This is an exact value for the length of x. However, occasionally we're going to ask you for the approximation, and then you're going to say little wigglies like that, and then you would say the square root of 39, and that's going to be approximately more than 6, right? And so that's about 6.24. So 6.24. So depending on what they ask you on the test, you know, whether is it an exact value would be this value here, exact value, and this would be an approximation. For this problem, it says the figure at right, sine of A is equal to 0.6. What's the length of BC? So we want to find this length right here. But we do know that sine of angle A, so meaning if I was here, sine of the angle A is equal to opposite over hypotenuse. And so in order to find BC, which is this length right here, opposite, all I have to do is take sine of A, which is this value, and plug it in right there. So I know that sine of A is equal to 0.6. So I'm going to go 0.6 in place of this A. So 0.6 over 1 is equal to x over 25. I'm going to cross multiply. I'm going to get x equals 25 times 0.6. And so that's going to be 0.6 times 25. It's about 15. So x is equal exactly to 15. All right. MNO, triangle MNO is shown below. Find the length of MN, which is this length here. So again, we're going to use right triangle trigonometry. And if you're standing right here at the length or the angle that you actually have, you would write this equation. You would say tangent. So you'd say tangent, because tangent uses opposite and adjacent and not the hypotenuse. So tangent of 52 degrees is equal to the opposite side over the adjacent side. Now, also, option 2 is, you know that 90 minus 52 is 38 degrees. So realistically, we could also move ourselves over here to this angle right here. And if by moving ourselves to that angle, we could also use tangent of 38 degrees is equal to the opposite side over the adjacent, so x over 12. And by doing that, what that does is it gives us, just cross multiplying. So we get x equals 12 times tangent of 38. And what that does is it just gives us a one-stop value. So we're going to go tangent. I always go tangent of 38, get that value first. And then instead of cutting it off, just hit right after that, hit times, and then 12, and then you have 9.375, so about 9.4. So I'm going to approximate 9.4, and that's the length of NM. So you'd say NM is equal to approximately 9.4. And you never put a line segment over a measurement, okay? Don't do that. Okay, so the right triangle below, find the values of A and B. So what this is right here is you've got a 30-degree angle. You've got 30 degrees. Opposite the 30 is equal to A. Opposite the 90 is 2A. So if that's 14, this is going to be 28. And opposite the 60 is going to be A root 3. So little a, this value A. I know, the letters are a little bit off-putting. But across from the 60 is going to be that A root 3. So if A is 14, so it's going to be A root 3, which is 14 root 3. I guess I shouldn't use that letter. I'll use, I don't know, T. Okay. All right. So this one says a window washer is standing on top of the building. Here's the window washer. Okay. He looks across horizontally. So I'm guessing that this window washer is like hanging here because he's looking across, he or she is looking across horizontally. Sees another building 20 feet away. So we're going to put that value in right here. It says he looks up that way at a 60-degree angle. So there's 60. Angle of elevation to see the top of the other building. He looks down, and an angle of depression to see the bottom of the building. So this would not be the angle of depression to see the bottom of the building. To see the bottom of the building, I got to go all the way down like that. And this would be, angle of depression is based off of a horizontal. So this angle, what's my angle? It's 45 degrees. So that's going to be a 45 right here. All right. So what do we know? It says, what is the total height of the building? So they want this length here, and then they want that length there. So we're going to add X, and then we're going to add Y. So let's put in our value. Let's just look at our values and see what we have. Across from the 30-degree angle, which I usually call A, is 20. Across from the 90 is twice of that, and that's going to be 40. But across from the 60 is A root 3. So this would equal 20 root 3. Now, across from the 45, remember, this is a 45, 45, 90. So this length here, 20, is equal to this length, 20. And if you wanted to, you could say that that's 20 root 2. But they didn't ask for that. They just wanted the total height. And they want our answer to be in an exact value. So it's going to be 20 root 3 plus 20. And that's going to be the total height of the building. So you'd box that up. Now, just a note, and this is in feet. So a couple ways to write this. Number one, you could write it like this, 20 times root 3 plus 1. And then all of this is feet. Or you could just leave it like this. And you'd say 20 root 3 plus 20 parentheses. And this is feet, like that. For this problem, given the isosceles triangle to below here, find the length of the altitude. So we're trying to find this height right here. And being an isosceles triangle, what you know is that not only are these two sides congruent, but the base right here is cut in half from this altitude, and those angles are right. So we're going to use our right triangle trigonometry. And so if you put yourself at this angle here, what we want to do is we're going to find this length of the altitude because that's opposite, the opposite side, and I have the hypotenuse. So sine of an angle is equal to the opposite side over the hypotenuse. So that's what I'm going to be using. And so we're going to say sine of 55 is equal to the opposite side over the hypotenuse, which is 8. I'm going to cross multiply and put a 1 under here. I'm going to get x equals 8 times sine of 55 degrees. And so I'm going to say, well, sine of 55 degrees is about 0.819, and I'm going to multiply that by 8. Not rounding, because you get a more accurate answer if you don't round. So we get x equals about 6.55. And so that would be the length of my altitude. For this problem here, it is asking me to find all the values here. So to find b, what I would do, first of all, is I would use Pythagorean Theorem. So I'm going to say 9 squared plus 12 squared is equal to b squared. So we have 81 plus 144 is equal to b squared. So I'm going to say 144 plus 81, that equals 225. So we have 225 is equal to b squared. And then to find b by itself, I'm going to take the square root of 225. Now, most likely for these problems here that I'm going to have to leave these in exact value, at least this first one. If not, my approximate value of the square root of 225 is 15. Yep. Now, what I was going to do, yes, I knew that. What I was going to do was this. I was going to say, well, 25 times how many values? And in this case, we've got 25, 25, right? There's 4 in 200. So there's 4 in 100. There's 8 in 200. And then there's 9 in 225. And so this would be 5 times 3, which is 15. So either way, yes, I know, 15. Okay, so 9, 12, 15. Oh, and another thing is that maybe some of you recognize this as a Pythagorean triplet, right? So if I divided 9 by 3, I would get a 3, I would get a 4, and I would get a 5, 3, 4, 5 right triangle, right? Anyway, so now that we know that b is 15, we would find cosine of angle A. So cosine is you put yourself at the angle that you're looking at, and cosine is adjacent, which is our 9, over our hypotenuse, which is 15. So on the side, I'm going to say, well, cosine of angle A is equal to adjacent over hypotenuse. So that's going to be 9 over 15. Now, the only other thing here is that's all they're asking me to do, is they're asking me to find that ratio, and that's what it equals, 9 over 15. You notice that they didn't ask me to find the measure of angle A. They just asked me to find cosine of angle A, and that's 9 over 15. But in order to find angle C, I actually need to find either angle C or angle A to solve this. So I'm going to finish this problem. I'm going to say angle A is equal to arc cosine of 9 over 15. So do that. So you would go second cosine, so that's your arc cosine of 9 divided by 15. Close that, and then you get approximately 53. So A is approximately 53.1 degrees. And so that's for angle A, but they are actually not asking for angle A. They're asking for angle C. So this is, even though that's 53.1, I have to take 53.1 and subtract that from 90 degrees. And I'm going to get 36.9 degrees. And so that is the measure of angle C. So I would say it's approximately, because we did have to round, 36.9 degrees. Okay. All right, for these two problems here, we want to find the measure of little a for this problem. So that's a tangent. Put yourself at the angle, and you're trying to find opposite. You're trying to find the opposite side. You have the adjacent, so that's tangent. So we're going to say tangent of 40 degrees is equal to little a, over 25. And so I'm going to cross multiply. I get little a is equal to 25 times tangent of 40. And so tangent of 40 is about 0.839. I'm going to multiply that by 25, and I get about 20.97. So A is approximately, just that side, is about 20.97. And they didn't, I don't know what they want me to round to, so I just have to wait and see as far as on that test what values that they want me to round to. For this problem here, they want me to find the angle. So put yourself at the angle they want you to find. And what do you have? You have the hypotenuse and you have the adjacent side, because over here is the opposite side, and I don't have that. So which uses the adjacent side and the hypotenuse is cosine. So we're going to say cosine of angle B is equal to the adjacent side over the hypotenuse. And in order to get B by itself, that angle, I need to move cosine over to the other side. And the act of doing that becomes arc cosine of 11 over 28. And so we have B is approximately, and so now I'm going to go arc cosine of 11 divided by 28, and I get about 66.87. So about 66.87 degrees. The next problem is saying a forest ranger spots a forest fire from the top of a lookout tower. So here's our tower, and here's this person here. Spots a fire. So they're looking down on the ground, and like, here's the fire. Bad stuff. The tower is 160 feet tall, and the angle of depression is 12. So note that this is what you have to remember, that the angles of depression is based on the horizontal. So that means that it's this angle is the angle that's the depression right there, not the one inside, but the one that's based off of the horizontal. How far is the fire from the base of the hill, tower? So this is what we're looking at right here, you guys. This is 12. That means that's 12 here. Because remember, parallel lines cut by a transversal give us congruent alternate interior angles, and that's what this is. This 12 here, these lines being parallel because they're both horizontals, that angle and this angle are the same. So now in order to find this length, this base, right, I'm going to use opposite adjacent, that's tangent. So tangent of 12 degrees, this being here, is equal to 160 over x. I'm going to have to cross multiply and divide this one. So we're going to get x times tangent of 12 is equal to 160. And so I get x is equal to 160 divided by parenthesis tangent of 12. So if you're going to go 160 divided by tangent of 12, please make sure you use parentheses. So tangent of 12 degrees, close the parentheses, I get about 752 feet. So the answer is going to be about 752.7 feet away. In this problem here, it says the ladder leans against the building. So here's my ladder. This is the ladder right here, okay? And it's leaning against this building, and it makes an angle of elevation of 49. So again, angle of elevation and angle of depression always deal with the horizontal. So if it's the elevation, it's the horizontal from the bottom up. And so that's going to be 49 degrees. And it says it reaches the point on the top of the building 12 meters, so we're in meters, above the ground. Find the length of the ladder. So this one is going to use the opposite side, and we're trying to find the hypotenuse. So sine of an angle is equal to the opposite side over the hypotenuse. So that's what we're going to use. So sine of 49 is equal to 12 over x. And we're going to cross multiply this. I'm going to get x times sine of 49 degrees, and that equals 12. I get x equals 12 divided by parenthesis sine of 49 degrees. And so 12 divided by parenthesis sine of 49 degrees is equal to about 15.9. So this is approximately 15.9 meters is our answer. For this problem here, they're asking us to determine which postulate or theorem can be used to prove that the triangles are congruent. If it's not possible to prove them congruent, write not possible. So for this one right here, we know, let's see, we know we have an angle congruent to an angle. We have a side congruent to a side, and we know that these are vertical angles, and so those are also congruent. So these two triangles are congruent by angle, side, angle. This one right here, actually, I have two options for this one. This is sort of an interesting one. Number one, I know that these two lines are parallel. For them to tell me that those lines are parallel, that means that parallel lines have they form congruent alternate interior angles. So number one, that angle is going to equal this angle down here. But at the same time, this angle is going to be congruent to this angle here. So if I did this problem like this, if I wanted to prove these two triangles are congruent, I would prove that they're congruent by angle, angle, side. So you have angle, angle, side. Now, on that note, though, I want to be clear that, yes, those angles are both congruent. But also at the same time, we have this angle in here congruent to this. These are vertical angles. And so an alternate way of solving these two, making these two triangles congruent would be angle, side, angle. And either one of these would be correct for this problem. For this one up here, we have a right angle congruent to a right angle. We have a leg congruent to a leg. That's it. This one is not possible because we don't have enough information. Maybe if they were connected, together, that would have been, if this was sort of flipped around and it looked like this, right, where I had this, let's say I had angle, this is a right angle, where this leg was congruent to this leg, and this leg here was congruent to itself by the reflexive property, they would be congruent by side, angle, side, but this one isn't going to work. For this one, you have to ask yourself, why are they giving me parallel lines? Well, parallel lines form congruent alternate interior angles. So we have an angle congruent to an angle. We have a side congruent to itself in the middle, and a side way out here. So these are also not possible because we don't have one that says side, side, angle. Yeah, so not happening. This one right here says these are congruent, but I need one piece of additional information in order to prove that they're congruent by what the value that they gave me. So they said this one is going to be congruent by side, angle, side. Notice that the angle right here is in between the two sides, which means that my angle is in between my two sides. So that means this one has to be VA congruent to TR. So you'd have to say that VA is congruent to TR, and then therefore they're congruent by side, angle, side. For this one, for these to be congruent by angle, side, angle, I have to have the side in between the two angles. So there's my angle, so that has to be a side there and a side there. So you would have to say AC is congruent to line segment DE. And for these two to be congruent by side, 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 we're just missing this length here and this length here. And so that's going to be IM congruent to US, line segment. For this one, we want to find all the sides and all the angles. And so what we've been given is across from the 90 of a 30, 60, 90 is 2A. So A, half of that, A is across from the 30, so that's 6. And then across from the 60 is going to be 6 root 3. Now, similarly, in a right triangle, that's a 45, 45, 90 that goes x root 2. Going backwards, we're going to take 12, divide by 2, multiply by root 2, and we're going to get 6 root 2, and that's going to be the length of both of these two sides. For this problem here, we're trying to find the length of a rectangle or the diagonal in this rectangular box. However, I don't have enough necessary information because in order to find that, I need this. I got 8. In order to find this diagonal, I actually need this length here. So this is sort of a two-step problem, because not only did you need to find this, you're going to use Pythagorean theorem here, right? These are right angles. To find this length, you're going to use it again to find D. So we're going to go part 1. So part A, we're going to go 6 squared plus 10 squared is going to be that purple diagonal. Let's call that A squared, okay? So we have 36 plus 100 is equal to A squared. So A is equal to the square root of 136. And I'm not going to reduce that because that gives me this diagonal right here, 136. But I'm not going to reduce that and spend my time doing that, because for the next part, I just have to re-square that, right? I'm going to go 136 quantity squared plus 8 squared is equal to my diagonal squared, which is then going to be 136 plus 64 is equal to D squared. And so what is that? 136 plus 64, that's 200, is equal to my diagonal squared. And so my diagonal is equal to the square root of 200. Now, that being said, I know that this is 100 times 2, but both in the roots. And the square root of 100 is 10. So my diagonal is going to be 10 root 2. And so that's the length of that. Cool. The perimeter of a square is 20. So what you need to remember about a square is it has 4 congruent sides. So 20 divided by 4 is 5. So each of these sides is 5. Your job is to find the length of the diagonal. And in a square, you know that these angles are 45 degrees. So you've got 45, 45, 90, 5, 5. That diagonal is going to be, that length is going to be 5 root 2. The perimeter of an equilateral triangle is 15. So again, divide that by 3. Each of my sides is 5. Find the measure of the altitude. In order to find the measure of the altitude, what you're going to do is we're going to cut 5 in half, and we're going to get 2.5. And so, okay, and then so we have a 60, 30 right angle, and so therefore across from the 30 is your A, across from your 60 is going to be our A root 3, which is 2.5 root 3. So the length of the altitude is 2.5 root 3, and then that's your answer. You can just leave it like that, that's fine. Solve for the missing leg. So again, this is x, and this is x root 2. Now in the last problem, if you didn't know what I was doing with that, we can do this a different way. There's a couple of different ways to find this answer. Number 1, you set 12 equal to x root 2. X root 2. And in doing that, so 12 equals x root 2. You're trying to get x by itself, so we're going to take 12 and we're going to divide by root 2. In order to do that, what that does is we can't leave a root on the denominator, so we have to multiply by root 2 over root 2. So we get 12 root 2 over 2. 2 is going to cancel into 12 6 times, and then I get 6 root 12. Okay, that's my answer for x. That's the length of the side. Second way is to use the little trick, the shortcut method, which says divide by 2 and multiply by root 2, and that's from right here. The third way of solving this is just to use Pythagorean theorem. If you don't know the length of the sides and you forgot all the little shortcuts, you can absolutely go x squared plus x squared is equal to 12 squared. 2x squared equals 144. X squared equals 72. And then when you square root both sides, you get x equals the square root of 36 times the square root of 2. And by the way, this is not 6 root 12. This is 6 root 2. Boom. Sorry about that. Typo. Fix that. And 36, the square root of 36 is 6. So you have 6 root 2. So again, another option for doing this problem. Solve for the missing 2 side lengths. So they want this, we'll call x. They want this, we'll call y. So first off, I'm just going to find... actually, what I want to do is I want to go 90 minus 79, of course, is 11. So I'm going to put that right here, because if I was standing here, I'm going to use tangent, and I'm going to go tangent of 11 degrees is equal to x over 18. I did that so that I didn't have the x on the denominator. So if I was at this angle and I went tangent of 79 equals 18 over x. When I cross multiply, I have another step. I have to divide then. Whereas here, all I have to do is say x equals 18 times tangent of 11. And so we're going to go tangent of 11 equals like 0.19, and then I'm going to multiply that by 18, and I get 3.49, so about 3.5. So x is about 3.5. So this is this value right here. So x is about 3.5. So here's this value here. So option A, again, to do the other part, is to do Pythagorean theorem. So 3.5 squared plus 18 squared is equal to y squared. So I could do that. Or I could definitely also use sine, cosine, or tangent, right? So which one would I use? I'm just going to use cosine and find y. So I could go cosine of 11 degrees is equal to the adjacent side over the hypotenuse. And when I cross multiply, I get y times cosine of 11 is equal to 18. So y is equal to 18 divided by cosine of 11, and you have to use parentheses. I'm not really sure that that's going to be any quicker than using the Pythagorean theorem, but what you do need to remember is that when you do divide, 18 divided by that cosine of 11, you have to use parentheses, and I get about 18.33, so y is about 18.3. And that's your x, that's your y. And had I done it this way, what would that have been? 3.5 squared, 3.5 times 3.5 plus 18 squared equals what? 336. And then when I square root that answer, I get about 18.33 again. So that I get the same answer either way, so you're fine. This one, find x and y, 30, 60, 90 special right triangle. Opposite the 90 is equal to 2a. A is across from the 30. So you basically take this value and cut it in half. So half of 40 is 20, and then across from the 60 is going to be 20 root 3. For a 45, 45, 90, it's 10, 10, 10 root 2. Again, 30, 60, 90 right triangles. Across from the 90 is twice what's across from the 30, so we're going to divide that by 2, and I get 3 root 3. And then across from the 60 is a root 3. Well, if this is a, because that's across from the 30, I'm going to put a right here. So that becomes 3 root 3, root 3, a little tricky. Root 3 times root 3 is 3, and then you have 3 times 3, this 3, and that's just 9. So the height, or x, is 9. For this problem here, what do? We have, before I forget, I did want to say this. Had I not done this, and had I just put myself at this angle right here, I could have used sine and said sine of 60 degrees is equal to the opposite side over 6 root 3, and then cross multiplied, and I would have gotten the same value. Okay. What we're trying to do is find x, which is way over here. So we know that this is x, and this is equal to x root 2, which means x is 3. So then we have 3, 3. And now we're looking at the 30, 60, 90, and across from the 30 is 3. Across from the 90 is 2 times that value. And across from the 60 is going to be 3 root 3. So x is equal to 3 root 3. For this problem here, find the missing leg. Now, what I would like you to remember is the Pythagorean triplets that you hopefully have remembered. And the triples are, we have the 3, 4, 5. We have the 5, 12, 13. This one. We have 7, 24, 25, and then we have 8, 15, 17. And of course, on this top one, we have the multiples one, which you guys have seen, 6, 8, 10. Remember, we saw that one that was a 9, 12, 15, right? So anyway, this one is a 5, 12, 13, which means x is 12, which means across from the r is 5, 5, 12, 13. So you're going to see these around like this. It is not necessary to show work for these triples, because you should know that these are there, and you should try to memorize these, and it just makes your life a little bit easier, right? Okay. This problem here is basically what we're, oops, oh boy. Hold on one second. Just lost all that. This problem, we just finished that one. Just a few more. This problem right here, a right triangle has one leg with leg length 7, and the other leg is 8. You're just trying to find the length of the hypotenuse. You will be asked this on the test. So, I mean, basically, we're trying to figure out if you do know how to use the Pythagorean theorem. We've got 49 plus 64 is equal to x squared. So x equals the square root of, find what's 49, add 64. So that's 113. So we have 113. So this would be an exact answer. This is what we call an exact answer. Then we have the approximations, which would then be the square root of 113, which is approximately 10.6. So x is about 10.6. And this is what we call a decimal approximation. Okay. For this problem, find the value of x. Again, you have all the sides. So you have so many options here. You could put yourself at this angle here, and you could say tangent of 51 degrees is equal to the opposite side over the adjacent side. You could go 90 minus 51 and get 39. Know that this is 39, and you could put yourself at this edge, and you could say tangent of 39 degrees equals x over adjacent, opposite over adjacent. You could say sine of 39 degrees is equal to the opposite side, which is x, over the hypotenuse. So any one of these is going to yield you the exact same answer. So I'm just going to use this sine of 39. I'm going to cross multiply, right? I'm going to get x equals 18 times sine of 39 degrees. So I'm going to go sine of 39 is equal to 0.6 something. Take that number, multiply by 18, and I get about 11.3. So x is approximately 11.3. For this problem here, you also have this side, which is 40, this angle, which is 40. I'm just going to use cosine for this, since I'll just put myself right here. And so I'm going to say cosine of 40 degrees. So this is option A. I could go cosine of 40 degrees is equal to x, adjacent, over hypotenuse. I could put myself at this side over here, and I could say sine of 50 degrees is equal to opposite side over hypotenuse, 75. So you have those options. I'm going to use sine again, and I'm going to say sine of 50 degrees is equal to about 0.76. I'm going to multiply that by 75, and I get about 57.5. So that means x is about 57.5. Okay. Find the value of x. This is asking me for an angle, and which means that I can actually, because I have all three sides, I can use any sine, cosine, or tangent. For example, I can say tangent of angle x is equal to the opposite side over the adjacent. Or I could say cosine of angle x is equal to the adjacent side over the hypotenuse. Or I could say sine of angle x is equal to the opposite side over the hypotenuse. And any of these, for any of these, I do have to use arc. So if I use the top one, I would have to say x equals arc tangent of 8 over 6, right? For this one, I'd say x equals arc cosine of 6 over 10. Zeros are going to cancel. You don't have to reduce that, by the way. For this one, I would say arc sine of 8 over 10. And so any one of these is going to yield me the same answer. So I'm just going to go arc sine of 8 divided by 10. I don't have to reduce that, but I get about 53.1. So x is about 53.13 degrees. And so that's this angle. This is this angle right here. And I have so many different options to find that, but that's how I did that. Your homework is to complete exit ticket number 8 on Canvas, and then we have some more practice for tomorrow, so stay tuned for part 2. Thanks so much for watching. I hope it helped.